Hi class, this is Professor Teixeira. In this video, I'm going to talk about process capability. And very briefly, process capability is the capability of machines to produce products within the specifications of design. Here we have one example, which is a bottle of water or a bottle of anything. And these bottles of, let's say, water, machines have to fill these bottles with 16 ounces. Okay, and then machines have to fill because that's what the company is selling. Sometimes machines, because of variability, because of let's say movement, because they're working, they go out of balance, and there is some variability that is accepted. For example, in this case, plus and minus zero point 0.2 ounces. That would be acceptable within the specification limits. The same happens to nuts and bolts and tires and windows and doors and everything that companies produce, screens, computers. They have to be in very defined specifications, otherwise they don't fit in what they were designed for. We have two measures to determine process capability of machines or in a production process. One is CP, when machines are centered. So going back to the example of a bottle of water, on average, the machine is filling bottles with 16 ounces. And CPK is when there is a possibility that this machine, because of vibration of anything that's happening, is filling on average 15.9 or 16.1. So it went out of balance and now is filling the bottles on average with less or more than what it's supposed to do, which is called lack of centering of the process. The same thing again with nuts, bolts, tires, and windows and screens and anything. Okay, machines or processes, they go out of balance and they start producing the products with a new average, which is the wrong average. Okay, so two measures. In this video, I'm going to talk about CP first. Okay, CP is defined as the difference. This is the difference between upper specification limit and lower specification limit. So what is the maximum and minimum that we accept the machines to do and still be good? What is the acceptable higher and lower, this upper and lower specification limits? And then we divide this difference by 6 times the standard deviation of what the machine is producing. Okay, this is CP. So there are three possibilities. CP is equal to 1, which means yes, the machines or processes are capable of meeting the specifications of the product. If CP is less than 1, which means the processes are not capable of producing within the specifications. And if CP is higher than 1, great, then the process produces with minimal variability. Okay, so here these slides, the charts to help, let's say, help illustrate. So this first one, machine is filling centered at 16 ounces each bottle, lower specific limit to 0.2 ounces below, 0.2 ounces above. As long as machines are filling up this amount, is capable. This one is not capable. You see that here is the lower specification limit, but there's some bottles of water that are filling up with less than 15.8, and some bottles of water are being filled with more than 16.2 ounces. So it's not capable, it's wrong. It's sometimes filling up more, filling less, okay? Not capable. And this one is above like 1 capability. So the lower specification limit is not even reached, and also not even the upper specification limit. So that CP would be greater than 1. So let's see how to compute this CP measure. Here we have an example. 3 bottling machines are being evaluated for possible use at Fizz plant. The machine must be capable of meeting the design specification of a lower specification limit of 15.8 and high upper specification limit of 16.2 ounces. With at least a process capability index of 1, they have to meet the specifications. Okay, so we have this table. Here's the formula. Okay, the CP is the difference between the upper and lower, which is 15.8 minus 16.2, which is 0.4. Okay, that's where this 0.4 is coming from. 15.8 minus 16.2, which gives 0.4. The company knows that the standard deviations for each machine are those 0.05, 0.01, 0.05, 0.1, 0.2. Okay, so this is the standard deviation. And this 6 times standard deviation is this number times 6, which is 0.3. This number, 0.1, times 6, which is 0.6. 6 times standard deviation, the standard deviation is 0.2. 6 times 0.2 is 1.2. Okay, so we have this information. Now it's very easy to compute these numbers. Let's see in Excel just to get it done. Okay, so here are the machines, standard deviation. Just copy the data to Excel, and it's easy to come up with this, right? The CP is equal to the difference between the upper and lower specification limits divided by 6 times the standard deviation, 1.3. We could do that, this formula for each cell, for each row, but I'm simply copying here because it's easier. Okay, so let's take a look at this one. Yes. All right, so you see that none of the first machine is more than capable. The first one is more than capable. The second one is not capable. The third one is not capable. Okay. What companies would do is, how can we reduce the standard deviation? You see that the standard deviation is killing these numbers. This 6 times standard deviation becomes too high. So what is happening with these two machines is that there is too much variability in how much they fill the bottles of water. They have to fix something, some parameters, like, I don't know, make some adjustments in the machines. They have to stop these machines and look at them and then fix, and then I don't know what they have to do. I'm not expert in bottling, but they have to reduce this variability. That's too much variability. Remember, operations management, we don't like variability. So they have, in these two cases, for machines B and C, we have to bring the standard deviation of these machines down so they became capable. Okay. Again, if we bring this variability to half, then this 6 times would be 6 times. Now it's capable. Okay, you see that it's capable. Let's try, even if we cannot make it reduced by half, but reducing, let's try 0.0657. You see, reducing by 30% variability in this machine B makes it capable. So this is what people in quality control do. Okay, I'm going to stop here and do the next video about the CPK. Stop.